Hey guys, I want to talk to you about chapter 5.6, which is factoring trinomials. I just talked about factoring by grouping, right? And so now I want to show you how to factor if there's only three terms. And so you can call it still factoring by grouping. You might also want to call it the AC method because that's what we're really doing. We're multiplying A times C and then factoring by grouping. So I'll show you a bunch of examples in this video that you can get comfortable with it and reference back to it. But here are the steps. So if you're given a polynomial ax squared plus bx plus c or anything else in quadratic form, then you're supposed to find the two factors of a times c that sum to b. That's called the AC method. You can really think of it as two different steps. First, multiply a times c, and then find the factors of a times c that add to b. From there, you're going to actually do what I call make change. All that this step really is separating the bx term into those two factors. So I'll also write that. Split b into those two factors from step one. From there, you'll have four terms, and so you can just factor by grouping. So if you can't factor by grouping yet, go back and practice that. Watch that video over and over and over again. Make sure you get it down. But I want to assume that I'm just starting with a trinomial now, something like 5x squared minus 11x plus 6. The steps are multiply a times c. 5 times positive 6 gives me positive 30. Maybe write it off to the side. It's not going to change my polynomial. That's just the first step, or part of the first step. Now I got to look for the factors of 30 that add to negative 11, that add to b. So I can play with the signs, but the factors of 30 are 1 and 30, 2 and 15, 3 and 10, and I just go down this list. So far, none of those have a difference of 11. So I keep going. 4 doesn't go into 30, 5 does. 5 goes into 36 times. So if I make them both negative, negative 5 and negative 6, they multiply to positive 30 and sum to negative 11. Then the second step says to separate that b term into these two factors that I found, the two that multiply to positive 30 but add up to negative 11. That first step is really the hardest step to get down. What am I doing? I'm multiplying 5 times 6 to get 30, and then finding the factors of 30 that add up to negative 11, because that's a times c, and the factors add up to b. The step I call making change is literally you just breaking up this negative 11x so that it becomes 5x squared minus 5x minus 6x plus 6. I like to call it making change because I'm asking you to break up an 11x into smaller x's or different x's. Like, hey, you got change for an 11x? Well, I got a 5x and a 6x. That works. The point is that now there's four terms. So that is the AC method. Now I just have to factor by grouping. And remember, you group the first two terms together, you group the second two terms together, you factor it out completely. Now, like I said in the last video, I've factored so much already that I can tell you how this is going to factor. From the first two, I can take out a 5x, and when I take out a 5x, that leaves me with x minus 1. From the second two, I see that a negative 6 would come out and join the 5x. If you don't see it yet, if you haven't done it enough, just group them. 5x squared minus 5x, those get grouped together. Negative 6x plus 6, those get grouped together. And I always put addition between them. Now I can take a 5x out of the first two, I get x minus 1. And I can take a 6 out of the second two, but since the leading term is negative, I'll take out a negative 6. Now they match, so I'm doing things correctly, and this is factorable. I pull out the x minus 1, and I'm left with a 5x from out in front and a negative 6 after. That's exactly the same thing that I got a second ago. So again, the more that you practice factoring by grouping, the less work you'll have to do. It just becomes natural. All right, so let me show you another one. All right, so let's say now that I'm dealing with 6x squared minus 13x plus 6. Again, what the AC method says to do is multiply this leading 6 by this last 6 to give me positive 36. So I'm looking for the factors of 36 that add up to negative 13. Well, there's 1 and 36, 2 and 18, 3 and 12, 4 and 9. And there are more factors, but right away I see 4 and 9 will add up to 13 if I make them both negative and still multiply to a positive 36. So I take 6x squared, I break apart that 13x to be negative 4x minus 9x, and then the positive 6 stays the same. So I could forget about all this work. It was just me trying to figure out how to separate this 13x into two other smaller choices, making change for them. Now I group the first two terms together, 6x squared minus 4x. Those get grouped together, plus negative 9x plus 6. Those two get grouped together so that I factor a 2x out of the first two, leaving me with a 3x minus 2. And out of the second two, I can factor out a 3, but since the leading term is negative, I pull out a negative 3, and that leaves me with 3x minus 2 again. Great, they match. 3x minus 2 gets pulled out, and then I'm left with a 2x minus 3. I want to show you one that has a common mistake that occurs. So let's take 2x squared plus, let's do 5x minus 3. When you multiply a times c, you get 2 times 3 gives you negative 6. Now you're looking for the factors of negative 6 that add up to positive 5, and so you have to be careful. 1 and 6, they have a difference of 5, but so do 2 and 3. So you got to be a little bit careful and play with the signs a bit. I want them to multiply to negative 6, but add to negative 5. So the only way that they're going to multiply to a negative 6 is if they have different signs, if one's positive and one's negative. These two multiply to negative 6, but they add to negative 1. And even if I change the signs the other way, if I made it a positive 3 and a negative 2, then they just add to 1 instead. So 2 and 3 is not the choice that I want. 1 and 6, I could make the 1 negative and the 6 positive. Now they multiply to negative 6 and then add to positive 5. So this is the pair that I really want. Be careful. That's a very common issue. When you separate it, you write it as 2x squared minus x plus 6x minus 3. I should mention that the order doesn't matter. So I'll do it again over here. I'll draw a line to remind myself to do it again, swapping the 6x and the 1x. It doesn't matter which you put first and which you put second. In this case, I group the first two, 2x squared minus 1x, and then I group the 6x and the minus 3 together. I can take an x out of the first two. That leaves me with 2x minus 1. I can take a 3 out of the second two, and that also leaves me with 2x minus 1. So that the factors match, that's great. That's my checkpoint. I know I'm doing things correctly. And this is factorable. I pull the 2x minus 1 out, and I'm left with x plus 3. But again, if you did 2x squared plus 6x minus 1x instead, meaning I'm keeping the same exact numbers, but I wrote them in the opposite order, just watch what happens. You group the 2x squared plus the 6x together. You group the negative 1x minus 3 together so that you can factor the 2x out of the first two. That leaves you with x plus 3. From the second two, nothing really comes out of them, but the leading term is negative, so I'd factor out a negative 1. If nothing comes out of them, the GCF is 1, you factor that out. And then since I factored out a negative 1, this becomes x plus 3 again, so that they match. Once they match, I pull out the x plus 3, and I get 2x minus 1. Compare that with this one, they're the same. What happens, because I wrote these factors in different orders, the factors end up in different orders at the end. But 2x minus 1 times x plus 3 times 2x minus 1, they're the same. So it doesn't matter. All right, try the problems. Let me know what you think. We'll practice factoring by grouping a lot, and it's going to be a big deal later. So you should get very comfortable with factoring. Do as many as you need to. All right.